Hi students, welcome to this course, PLC Automation, an Introduction to Programmable Logic Controller. I am Professor Yao. Industrial 3-axis robot with PLC control. The keywords: extend and retract, air valve, erasable programmable read-only memory, EEPROM, integrated circuit chip, IC chip, color code, wire numbers, a 16-output PLC output module, interlocks, part in place indication, home position. Industrial 3-axis robot with PLC control. An industrial type robot is shown in figure 20.7. It has various motion and gripping capability similar to those in figure 20.1, namely, arm moves up or down, elevate. Arm rotates 180 degrees. Gripper rotates 180 degrees. Gripper opens and closes. Gripper extends and retracts. Slide left or right. 5 stations. 2 ends and 3 intermediate. The robot shown in figure 20.7 is operated by applying 110 volts AC to various pneumatic solenoids. Each solenoid, when energized, lets its air valve supply air for operating the various functional motions. When off, no air is supplied, and the function is in its initial position. This industrial robot differs from the previous one in that motion ceases when a function is de-energized. It also differs in that some opposite motion require 2 inputs, one for each direction. Various control methods are used to operate the robot or to program the robot to operate automatically. These include manual control, mechanical drum control, erasable programmable read-only memory, EEPROM, integrated circuit chip control, and a computer control. Before programming the PLC to control the robot, you must develop a scheme to connect and interface the PLC with robot. Figure 20.8 shows the pin connection to the robot and the necessary color code wire numbers of the connecting cable. Since the robot uses 110 volts, you need a 110 volts interface input-output I/O for PLC input and output. If you connect the ground and a group common connection by direct wiring, the PLC needs only 13 output ports. You therefore would choose a 16 output PLC output module. Figure 20.9 shows a block diagram of this control scheme. Note that interlock are not considered in this discussion, but would be included in advanced programs. Figure 20.10 is a drum sequencer programs constructed on a program coding sheet. Blank coding sheets are furnished by the robot manufacturer for ease of program formulation. The sequential steps of operation go from top to bottom. A step description is written on the left of the sheet under sequence of events. The off-on pattern is indicated by X for on and a blank space, or sometimes O's for off. A listing of functional status for each motion is listed along the top. Rotate counterclockwise, rotate clockwise, etc. The sequence of events to accomplish the operational objectives is determined and listed. Then the X are filled in for the function that will be actuated. The final part of the procedure is to record the assigned PLC operation numbers for each step. Our program used the output group 2 register, OG2. Therefore, the 16 individual outputs are 16 through 32. A cross reference of cable numbers and the letters corresponding to operational numbers is shown at the bottom of figure 20.8. Figure 20.11 shows a typical PLC program that could be used for the robot sequencer program. It is operated on a 5-second time interval. As set in the time program, note that the pattern of regular bits corresponds to the coding sheet of figure 20.10. Only the first 12 bits are needed, because there are only 12 functions to be controlled. In actual operation, for equipment and the personnel safety, the program could be entirely or partially event-based. There could be limited switches or sensors for position or part-in-place indication. And ensuing operational steps would not be able to start until the preceding step is completed successfully. For example, if there were no part to be picked up, the sequence would stop or the arm would return to the home position. This picture shows the industrial pick and place robot. This picture shows the robot control cable pin number scheme. This picture shows robot PLC control system block diagram. This figure shows program code sheet for PLC. This figure shows PLC robot control program and a register pattern. Exercise 3. The keywords. 6 active position. A positioning solenoid. Arm extend and a gripper close actuators. A coil and a contact PLC program. Develop a program. Exercise 3. The workstation or robot in figure 20.12 is similar to the one in figure 20.1. It differs in that it has 6 active positions, not 4. It has a positioning solenoid for each of 6 positions shown. It also has arm extend and a gripper close actuators, as in figure 20.1. Develop a coil and a contact PLC program to accomplish moving a part from LM to UR. Also develop a program to move a part from UR to LL. This picture shows the diagram for this exercise. Exercise 4. The keywords. A timed sequence program. Initial position. Pick apart. The robot shown in figure 20.13 is similar to the robot in figure 20.7. Develop a timed sequence program, times of your choice, to accomplish the sequence above. An example program was illustrated in figure 20.10. Initial position is as shown. Pick a part at A5. Move part to B4. Return to initial position. This picture shows the diagram for this exercise. Homework. Handwriting of keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.